Okay, so A, they want us to find the curve length of AC, referring to this part. Okay, so we can find it by essentially finding the fraction of the whole circumference of the circle that we have in our current diagram. So how we're going to find that fraction is using the 120. So our one full circle got how many degrees? Anyone remember? One circle got how many degrees?
360.
360. Yes. So if our whole circle is 360, we are going to find a fraction, which is this 120 lah, of the circumference. So my part A, okay, curve length AC is going to be 120 over 360 of the whole circle. So this gives me my fraction. And I want to find the circumference. So my circumference is 2 pi r. So 2 pi times my r, which is 5. So the question, they told me to do it in terms of pi. So that's a good thing. I don't have to have a long number. I just need to put it in terms of pi. 120 over 360 is equals to 1/3. Okay, so you end up with 1/3 times 2 pi times 5, end up with 10 pi. I will put it as 10 over 3 pi. Okay, this one you can leave it as an improper fraction, it's okay. Because to be very honest, when you leave something in terms of pi, pi kind of acts like an algebra, right? A letter, an alphabet, A or B. So when we deal with algebra, usually we leave our coefficients, okay, in terms of improper fractions. So same idea lah. Okay, pi it's kind of like a algebra. So B, then we talk about the base radius of the cone. So like I said just now, when I have my arc length here, okay, this is the part of AC that we found. When I roll it into a cone, it becomes my circumference of my base. So I'm going to be using this circumference of the base to find my R here. So my radius, based on the fact, I can say that 10 over 3 pi is equals to 2 pi R. It is the same. Okay, the same circumference of it. It's the same circumference lah, essentially. So then I can do my cancellation. My pi I can cancel out. So I'm left with 2r is equals to 10 over 3. I flip the equation. R equals to 5 over 3. Okay, in this case, I will convert into mixed number because this one is a number itself. There is no pi or anything. I will put it as 1 and 2 over 3 cm. Okay, this one more accurate. Okay, 1.6666 very long. Never ending. Okay, so this will be a bit better, more accurate. It's okay to leave it like this. Then we talk about the height of the cone. So the height of the cone, okay, we can use to find. So this cone, we usually, in order for us to find the height, we will use Pythagoras.
How do you know?
So same situation, we have this cone, okay. Okay, I bear my drawing. The drawing I'll be close eye, okay. Just trying my best. So we have this okay, this right angle triangle where my slant height, okay, is my hypotenuse, and then I found my R, which is 1 and 2 over 3. So using Pythagoras, I can therefore find my perpendicular height. So that is what I'm going to do. Okay, so whenever you use Pythagoras, all my students all complain. Okay, you need to write by Pythagoras theorem. Please go and learn how to spell his name. Spell the name wrongly also minus marks. The worst way. Okay. He made a very important theorem. Let's be respectful. We all spelled it incorrectly. Pythagoras. Ooh. So Pythagoras, the apostrophe is after the S. Okay, for apostrophe, a lot of students also forget. So by Pythagoras theorem, I can say that my h, okay, my height. If you want, you can do this and label h first, okay, so that you can use. But honestly, if you never go and label h, please go and write height. Okay. So height is equals to my square root the whole thing. Yeah, okay. Oh, my line break. My hypotenuse, which is 5 cm, so 5 square, minus the 1 and 2/3. Okay, so I wouldn't really put this value in. I will put 5 over 3. Easier to square. If not, later you'll be fighting for your life. Okay, 5 over 3 also easier to type in. Okay, this you put into calculator, you should have a nice number. Okay, so always put in 5SF first. Okay, you will never know when you will use it. Always put in 5SF. So you put in 5SF, will be end up with 4.7140 cm 5SF. And last but not least, final answer have to leave in 3 cm, 3 cm, 3SF, 4.71 cm. 3S. And this is my answer for part C. So use Pythagoras theorem. This one we already should teacher Ben should have talked about it previously last week. Okay, then last but not least, we are going to find the volume of the cone. So volume of cone, okay, as always is 1/3 pi r square times the perpendicular height. Okay, very important. It is not the slant height, it is the perpendicular height. Okay, volume of height, what am I writing? I see I talk about height, I'm going to talk about it right now. So volume will be 1/3 pi r, radius in this case is 5 over 3. I can use that. 5 over 3 square times my height, which I'm going to use 4.7140. Okay, don't use a 3SF value. The 3SF value is not accurate enough. Okay, even though to you it might not look very different, but to the invigilator it makes a difference. 5 times 5 over 3, 4.7140. We end up with a nice 8.2275 cm square, cm square, cm cube. 5SF. Remember to round 8.23 cm cube. This is sorry. Yeah, wait, hold on. I will made a mistake. Sorry. I made a mistake. I forgot to square. 0.3. 8.7. And this is my answer. All okay so far, Ken? Okay, so it's a breakdown like one bit by bit. Okay, so the good thing is not to worry, usually it will be guided. So A, B, C, D, there's a part by part way to guide you to the question. Okay, this question is quite big.